So the big two ideas in statistics that we are going to talk about are confidence intervals and hypothesis tests. So we've already talked about hypothesis testing in our one categorical variable part 2 set of notes. So now the part 3 is then focusing on the confidence interval stuff instead. So first, just as a reminder, I put these things in here in case you do want to look at the book. The one thing with this set of notes, I don't use the exact same conditions as the book. I use the ones that are very similar to what we've already used in past examples. So to understand the idea of why we would want to do something called a confidence interval, let's start by looking at this example. So we saw from a random sample that was collected of 600 Boone County elementary school students, 29% of them were eligible for free or reduced lunch. And the question we're asking is, does that mean that 29% of all Boone County elementary school students are eligible for free or reduced lunch? So the first thing let's focus on are the numbers that we are given and what they actually represent. Right, so this 600 given to us was our sample size. And what is this 29% or this 0.29 that they gave us? Well, it is a proportion for sure, but where is it coming from? It's 29% of our sample, right? So this 0.29 is a p hat. So then what I'm really asking you here is, does that mean that 29% of all Boone County elementary school students are eligible for free or reduced lunch? So what I'm wondering is, does this stuff imply then that p, the population proportion, is also 0.29? Well, we don't know that, right? So we really don't know. It could be, but it also might not be. And why not? So it does not imply that, because this is just a sample of students, right? Not all of the students. So even though we hope maybe it's close to that 29% that we got, we cannot say for sure that that means that 29% of all Boone County elementary school students were eligible for free or reduced lunch. However, based upon this sample proportion and sample size that we have, right, we learned a model to tell us what we could know what to expect. So we knew that under certain conditions, that p hat was approximately normally distributed with a mean of p and a standard deviation of the square root of p times 1 minus p over n. Right, those were things we talked about way back in the one categorical variable part 1 before exam 1. So we already know that. And from that, we learned how the numerical rule applied. More specifically, I'm going to focus on that 95%. So how do I get 95%? That means I go out 2 standard deviations. So if I look at my picture, I know that it's going to be centered at p. And this is my distribution of p hat that we're looking at here. And if I go out 2 standard deviations in both directions, so if I go out here and I go out to here, then I'm going to get 95%. Alright, so how do I actually find, though, this value of A and this value of B? So how do I actually find those numbers? Well, we're going to do exactly what we said. So this is going out 2 standard deviations below. So I'm going to start at P. I'm going to subtract off 2 standard deviations. And what's my standard deviation? Well, it's just this square root part that we have up here. Right, so that's how I would actually find that point from a mathematical standpoint. Right, once I actually numbers, I can actually do the subtraction and figure out what that point is and what that point is. So B, we're just doing the opposite, right? We're going up 2 standard deviations. So we're also going to start at P, but this time we're going to add 2 standard deviations. So 95% of our sample proportions would be between these 2 numbers. Now this is great in theory. There's a couple of problems with this picture. And let's actually go back up to our example to understand. So I collected my data on 600 Boone County elementary school students, found 29% of them were eligible for free or reduced lunch. Well, I decided that P, I don't know for sure, it could be 29%, but it might not be. What is P? Do we know what percent of all Boone County elementary school students are eligible for free or reduced lunch? Nope, that's our biggest problem. We actually don't know what P is. And hopefully first of all it makes sense why I wouldn't know it. I would not go out to estimate what percent of all Boone County's elementary school students are eligible for free or reduced lunch if I already knew what that number was. If I already knew what P was, I really wouldn't need to go out and collect a sample about it to figure out what it is. So I'm not going to know it. Now, why is that actually a problem for us? Well, what number goes along here? So if I asked you, where does P hat of 0.29 belong on this picture? Is it smaller than P or is it bigger than P? We don't know. Like, right, I don't even know where to put this number on my picture if I don't have this number as a reference point at all. Now, the second trickle effect, if I don't know what P is I need P to also calculate my standard deviation. So I actually don't also know my standard deviation. So we don't have that either. Alright, some good news. We might not have P, but we do have P hat. So what I might be able to do is do a similar calculation to this with using P hat instead of N. But let's talk about what that would actually mean and what that would cause to happen. So first I'm going to draw my general picture again. But this time, instead of putting 95% in the middle, I can really put any percent in the middle that I want. It doesn't matter. And at some point, no matter what percent I put in that middle, we're going to end up with this A and this B end point that we're working with. And again, still we're looking here at the distribution of P hat. So if I want to take my interval here that I just created and not use P but use P hat instead, what is that going to mean? Well, P hat is some number that falls along down here at the bottom. Again, I don't know exactly where it falls, but it falls somewhere along down here at the bottom. Now, if P hat falls between A and B, when we construct our interval using P hat, this interval will contain P in it. So by that idea, if I had P hat somewhere over here, and I go out 2 standard deviations in both directions, P will be inside of that interval. Now, I'm not saying where in that interval, but it's going to be somewhere inside that interval. Now, if the opposite were true, so if P hat is not between A and B, when we construct our interval, it will not contain P. Or since if I was way out here, if I go out my 2 standard deviations, I'm not going to quite make it to P. It's not going to be inside my interval. Now, why do I actually want it to be inside my interval? Is the goal is we have this sample proportion. So for example, our 29% from that opening example. And I'm saying, well, I have this 29% and I realize it's only a sample proportion. That does not mean that 29% of all Boone County elementary school students are eligible for free or reduced lunch. But what I hope is my 29% is close to the right number. So instead of saying 29%, I'm going to create an interval around it using P hat, and I might come back and say, well, I believe that between 25 and 33% of all Boone County elementary school students are eligible for free or reduced lunch. Now I'm giving you a range, like between 25% and 33%. Now what I would like to be true is that somewhere between those 2 numbers I just gave you is where the percent of all Boone County students being eligible for free or reduced lunch falls. But it is somewhere between those 2 numbers. Now notice, it might not be. So what do I want to do because of that? Well, going back to my picture, I didn't actually put a percentage here in the middle. I'm going to generically write this as 1 minus alpha, and alpha is very similar to what we saw back in our 1 categorical variable part 2 notes with hypothesis testing and being a significance level. If this is 1 minus alpha, sort of these little leftover pieces, or that whatever alpha is divided by 2, just to kind of have a complete picture. And how would I actually use this? Why am I even giving you this? Well, what 1 minus alpha actually is the probability that the interval contains P. So whatever percentage I decide to put in the middle is the probability that my interval will contain P. So as you can probably guess, we want this to generally be a pretty large number because I want to have a large probability that my interval contains P. So that's our goal. So depending upon how precise we want to be, we can change this numbers. And once I create this interval, it's what's called a confidence interval. So when we get back together in class, we're going to take this idea, show you what the actual formula looks like how do I actually come up with this interval using P hat instead of P. We're going to talk about how we figure out what number is here and how does that affect our endpoints as well. But I know right now if I wanted that 95% idea in the middle, I would go out about 2 standard deviations. But again, I can change this number depending upon how precise I want to be. So that's what we will talk about next time in class.